Here is the failure I keep seeing. A server passes a vulnerability scan, the package is current, and the firewall is tight. Then we look at access. There are 6 authorized keys files nobody owns, a contractor key from last year, and one host where password login is still enabled, because a rescue change was never reverted. That is not exotic. That is normal config drift. Today we are doing an SSH audit configuration pass. Who can log in? What algorithms are accepted? And which hosts disagree with the standard? An SSH audit is not a penetration test against someone else. This is administration work on systems you own. The point is to turn assumptions into evidence. You want a current list of keys that grant shell access. You want to know whether the daemon still accepts older algorithms. You want the effective SSHD configuration, not just the lines someone remembers editing. And across a fleet, you want to know which host is different. The cheapest hardening is removal. Remove unused accounts, unused keys, old compatibility settings, and duplicate config fragments. Less exposed surface means fewer surprises during an incident. Mechanically, SSH access is the result of several layers. The server reads SSHD config, any include files, compiled defaults, and possibly match blocks. Then, for public key login, it checks the target user account and that user's authorized keys file, normally under .ssh in the home directory. Algorithm settings control what key exchange, cipher, MAC, host key, and public key signature algorithms are allowed during negotiation. That is why reading one file is not enough. You audit the daemon's effective view with sshd-T. You audit access by finding authorized keys files, then you compare hosts to catch drift. First line, run sshd-T as root, then grep for the settings you care about. This dumps effective lowercase directives after OpenSSH has applied defaults and parsed config. The grep shown catches root login, password authentication, key exchange, and ciphers. Add max, pub key accepted algorithms, and host key algorithms when you want a wider algorithm view. The find command inventories files named authorized keys across the machine. Review the results. Unusual paths matter. SSH keygen-l-f file prints fingerprints from a public key file, including authorized keys. The final sorted SSHD output is what you save and diff between hosts. Here is the pattern I use on a small fleet. Pick one known good host, run sudo sshd-T, sort it, and save it as the baseline. Then run the same command through SSH on each peer host and save one file per host. Diff each file against the baseline. Maybe one host has password authentication, yes. Maybe another has a custom ciphers line copied from an old hardening guide. In parallel, inventory authorized keys everywhere and map each key to a person, automation job, or break glass procedure. If nobody can name the owner and purpose, disable it first, then remove it after the change window. The big mistake is confusing RSA keys with RSA SHA-1 signatures. Lines beginning SSH RSA in authorized keys are RSA public keys. Modern OpenSSH can use RSA keys with RSA SHA-2 signatures. The risky compatibility switch is accepting the SSH RSA signature algorithm, which means RSA with SHA-1. Check pub key accepted algorithms in sshd-T. If SSH RSA or plus SSH RSA appears there, understand why before keeping it. Also look for SSH DSA keys. DSA should be gone. Another trap is match blocks. Plain SSHD-T may not show a specific user case. Use SSHD-T-C with user, host, and address criteria when testing match behavior. This audit sits between basic configuration and serious hardening. If you do not know the current state, every security change becomes guesswork. Before disabling password authentication, know where it is still enabled. Before rotating keys, know where old keys live. Before writing detection rules, know what normal SSH access looks like on your own servers. This also connects to central logging, bastion hosts, certificates, and configuration management. The audit gives you the facts those later controls need. It is not glamorous, but it is the work that keeps clean designs from rotting. On your own VM or workstation, do this in 5 minutes. Run the sshd-T grep command and write down permitroot login, password authentication, kex algorithms, and ciphers. Then run find for authorized keys. If you find more files than expected, do not edit yet. Pick one file and run ssh keygen-l-f against it to print fingerprints. Make a small table: path, account, key fingerprint, owner, purpose, keep or remove. If this is a shared machine, stop there and review with the owner. Good audits create safe change plans, not surprise outages. 3 beats to keep. First, SSH access lives in authorized keys files, and those files spread over time. Inventory them. Second, audit the effective daemon config with sshd-T. Do not trust memory or one edited file. Third, diff hosts so drift becomes visible, then remove what you no longer need. Removal is the cheapest hardening you will ever do. Tomorrow we keep building the practitioner layer with another SSH administration and defense topic. New SSH episode daily on this channel, from zero to expert. And as always, the daily ranked CVE brief is linked in the description.